Here we're back with another tutorial. I will set up with Flutter Rust Bridge. So in the last session I have shown you how to set up Rust native code in our Flutter projects, how to install required libraries and packages, and how to use the exact version number to match with our Flutter Rust Bridge code gen that we install in our machine. So okay, let's get started. So the first thing what we are going to do is we will build a static build for our iOS, because iOS only accept static build. That's why we are going to build that static build with the help of Cargo Lipo. So let's install that first. Cargo install Cargo Lipo. So we will install that, and then and go to our native folder and let's run that command cargo lipo. So we don't need to do anything, just cargo lipo, and it will generate arch64-apple-ios folder and another folder called x8664 apple ios. As you can see in the target, we have two folders. The first one is for real device, and the second one is for the simulator. So the universal one is this one and this one combined one, so universal one. So we will use this universal build in our iOS. Okay, so let's copy that file first. So we are in the native folder, so we can directly call target and then go to universal debug and the name of our build. So as you can see here, without the lib, the name would be Rust Flutter Teach Demo. So how the name is coming from? Here we declare in here Flutter Rust Flutter Teach Demo. That's why it is available with the name. So we will copy this into iOS runner folder. So let's copy that. // go to our project root and then the iOS folder and then the runner. So hit enter. So .a file will be created, will be copied there. Yep. So the next step is we need to run our Flutter Rust Bridge code gen to get the header file. So in the last session I didn't show you how to how to generate a .h file. So I'm going to show you right now. Okay, Flutter, go to cd and go to the root folder and run Flutter Rust Bridge. And this all, I hope everyone is familiar with this. If you don't familiar how to use Flutter Rust Bridge code gen, and go and watch my previous video. Set up Flutter Rust Bridge in Flutter. Yeah. So -r will be the Rust input path. That input path will be API no.rs. So native API SSC API no.rs file. -d would be the dot generated output file. So it should be inside the lib folder. So lib /bridge bindg bridge generated file, and then the dot decl output lib bridge bindg bridge definitons definitions file, and the last one is the -c header file. It should be inside the iOS /runner/bridge generated.h file. So okay, and the problem here is .decl output doesn't find decl output. Oh, sorry, I typed around there. As you can see, it should be output. Right now it is becoming output. Yeah, so let's type correct. Let's use the correct name and then hit enter. So it will generate our generated file in Flutter and also for the iOS. And let's go to iOS runner. Let's check our header file. So here, this is the header file. So the next step, we need to use this header file from app.delegate.swift file. So we need to tell Flutter that in our iOS setup, we need to tell that we will use the bridge header file. So we need to import that header file in here, rana-bridges-header.h file. So let's go and import that. Shep import, and then the name of the header file, it is bridge generator.h file. Okay, cool. So after importing, so we can now able to call all the function inside the header file. The function we are going to use right now is demi method to enforce bundling. So I will copy this. Let's go to build applicator Swift here. Let's call the function. Yep. So and that's all done in the code side. So let's open up the iOS folder in Hcode. So we can use a command called open and go to iOS, run, and then the XC workspace. So we will open this app in Hcode, and we will tell Hcode that we are going to use this static build.a file. So okay, let's wait for Hcode to open up. Okay, Hcode is opening here. So in here, let's go to our build phase. In here, go to Rana, and then there are two Rana, project Rana and target Rana. Select the target Rana. In the build phase, go to link binary with libraries. Build phase, and then link binary with library, and then we hit plus icons, and here there is no .a file, so we know that .a file is inside the runner folder. So add other, add file, and then go to runner, and then add that static build. Okay, that's cool. So everything is set up in our iOS setup path. So let's go and set up in the Flutter. So as I already told you, FF5 will load the build so that we can call the Rust related function from Flutter. So okay, I make a little bit of snippet, and you can call a note. So I will copy from there. Let's copy this and put it in our main file. You can put this code whatever you want, because right now at the moment we have only main.dat file. So I will put it in here, and the name of the base const base, the name will be Rust Flutter Teach Demo. So the name is related with the Cargo Toml lib name. So native Cargo Toml lib name. Yep. Okay. So platform is coming from .io, and then dynamic library.process is coming from the .ffi package. Yeah, everything's great. Let's remove the late data type, and here, as you can see, platform we made a conditioner here. If platform start window, it will use the base.dll. If not, it will use lib-base.so. Okay, great. But first thing, it is platform.is iOS. It will call dynamic library.process. That's all. Nothing fancy. So right now we are testing for iOS. That's why the dynamic library.process will trigger here. So we don't need to provide any name. But in Flutter we have Android, macOS, Linux, Windows. So they have different type of code to load the static build or dynamic library. Yep. So the implementation would be come from the bridge generated. So as you can see here, Rust Flutter Teach Demo implementations. So it is also related with the name. So you can just call, if you don't know how to call that, you can just call uppercase first letter and the small letter, and then demo implementation. So let's put the divinely lib. Let's go and check that function. It is inside the bridge generator.h, accepting a external library dynlib. So we will pass that here. So right now we can call our function to call Rust native code. So let's call it. When we press this button, we will get data from Rust. Okay, and Rust get data from Rust, and then API. So API is coming from here. So let's API dot greeting from Rust. So this function is coming from the bridge generated. So actually it is coming from the API.is. When we do Flutter Rust bridge codegen, so it generated the dart file. That's one we can call with our dart related code. Okay, so greeting from Rust is a future that returns a string. So let's put await in here, let's put a sin in here, and then we will print it out in the console. Okay, great. That's all. We set up the let me recap a little bit. We generate a .h file. We tell that we will use that .h file, and then from app.delegate.swift file, we call the header function, and then see we add the static build in our S code, yeah, from random build phase and link binary with libraries. Okay, so and the next thing is in our Flutter we wrote a little bit of code that load the static build in our Flutter, and then now we can call the function. Yeah, so let's test that. So I will open up my simulator. To open simulator, you can use this commands or not. You can manually open it. It's depend on you. Yep. So emulator is open. We will hit Flutter run and run the projects. So great. In here, the bill will be filled. That's why I'm showing this error. I want to explain the error why our project failed. Let me show you. It will definitely fail because I will explain later when it fail. Let's see. Let's check it out. Okay, compiling, linking, assigning. So as you can see here, building for iOS simulator, but linking in an object file. So the object file is the ARM64, meaning that the universal have two architecture, that is ARCH64 and the x86_64 file build. So there are two build, but right now we are building for simulator, so it is not using this one. It directly using the ARM64 architecture. That's why we need to tell Hcode that we will not use simulator for iOS. We will not use the ARM64 architecture for iOS simulator. So let's go and tell in Hcode. In Hcode, target runner, go to build settings, and then choose the all. And in our iOS simulator SDK, let's click it, exclude architecture. So we will exclude architecture ARM64 for iOS simulator SDK. So in here also we will put ARM64, and then in here also I will put ARM64. Okay, cool. So after excluding the ARM64 for iOS simulator SDK, we can now we can now run and build the project successfully, because after telling excluding the ARM64 architecture, the iOS simulator will use this one only. So this one is for Flutter iOS real device, not meant for the iOS simulator. So there are different type of architecture. Actually, this not specifically built for the iOS simulator, but we can use. But let me show you for the architecture that only related with the iOS simulator also. Okay, so this project setup is for you can run in both simulator and both in real device also. You don't need to change anything. That's fine. Yeah. So after clicking click me to get data from REST. As you can see, hello world is printing. So hello world is coming from here, api.is. Okay, cool. Let's change something called greeting from Rust. Okay, cool. So let's close this, and then let me show you another that specifically build the architecture for the iOS simulator. So let's go to the native, and then we will call cargo lipo, and then dash target equal not equal dash target aarch 64 iOS Apple iOS sim. So this is okay, so something is wrong here. Okay, let me check cargo lipo dash help. Dash targets, so we missed the S. Sorry, no problem. Okay, cool. We hit enter and it will build the architecture for iOS simulator only. So in our universal, and the build is replaced with this one because ARCH architecture for iOS sim has only one here. So let's remove to see clearly if you understand what I'm saying. That's why let's delete the build and let's run this build again, cargo lipo dash target. Okay, so in target there is only one folder and the universal is related with this one. So we will copy that universal build. Let's go to target universal debug and then .a file into our iOS folder runner. Yep. Okay, cool. So we already used right now the build is iOS simulator architecture. That's why we don't need to exclude the ARM64. Okay, let's remove that. We don't need to remove because it is specifically built for the iOS simulator, so it will work. So the problem with the iOS simulator is that if you want to test in real device, it will not work because it is only built for the iOS simulator architecture. That's why. So let's click it and then, oh sorry, it's still building. Wait a few minutes. Okay, let's go build then. And then let's click it and it will say greeting from Rust. Yep. So I show you how to set up in iOS and how to set up in how to use the static build in the Xcode, and then how the different architecture relate with the iOS simulator and the real device. Yeah, so that's all for the tutorial. Maybe tomorrow I will show you how to set up in macOS with the help of Cargo Xcode. Okay, today we use the help of Cargo Lipo. Yeah, thank you everyone.